Dear student, we're discussing on photochemistry. Today we discuss on next topic of photochemistry. This is the important in your syllabus and your examination according to your examination. Today's our topic is the photochemical laws. In the previous lecture, we discussed on excitation and absorption. Today we discuss on photochemical laws. Photochemical laws are these types of the photochemical laws. What is the Lambert's law, Beer's law, Grothus-Draper law, and Stark-Einstein law. These are laws of the photochemical laws. Some laws like as Beer and Lambert we discussed in previous undergraduate courses. Some summarize we discuss on Lambert law. Lambert law is we can say that monochromatic light we use and passing through a homogeneous medium. Homogeneous medium, that is after we can say that minus di upon dx is equals to ki. This is the equation number 1. Here I is the intensity of radiation after passing thickness of X medium. That is the X medium, like is that this is the medium and this is the I is the intensity of radiation after passing the thickness of X medium. Here is the thickness is X and here is radiation in goes through by this and here is I. Di intensity merely small decrease in the intensity of radiation on passing through infinitesimally small thickness of dx of medium. And di upon dx a negative, that is minus di upon dx is equals to rate of decrease in intensity of radiation with thickness of the absorbing medium. Here k is the proportionality constant or known as the absorption coefficient. After that, value of k depends upon the nature of absorption medium. K is on depend on absorbing medium. If I0 is the intensity of incident radiation and I is the intensity after passing through the thickness of X, that medium, that is the this condition I0 to I, because I0 is the intensity of the incident and I is the intensity of passing through the thickness. Then in integral on I0 to I, di upon I is equals to minus k dx is x tends to 0 and x tends to x. After that integrations we can say that log it was ln I upon I0 is equals to ks. Then I upon I0 is equals to e minus kx, that is I is equals to I0 e minus x. That is the Lambert law. That is the Lambert law. In equation number 2, that is the Lambert law. Now we discuss on Beer law. Beer law is the when a beam of monochromatic radiation pass through a solution of the absorbing substance, rate of decrease in the intensity of radiation with thickness of the absorbing medium is proportional to the intensity of incident light as well as concentration of the solution. This di minus di upon dx is equals to k dash ic. Here c is the concentration of the solution and k is the molar absorption coefficient. So here also integration I0 to I according to above equation Lambert law, that is I0 to I di upon I is equals to minus x is equals to 0 and x tends to x k dash c dx. Here k is the proportionality constant, c is the concentration, that is a ln I upon I0 is equal to k dash cx and I upon I0 is equal to e minus k cx. On Lambert law, I is equals to I0 e minus kx, that is here I is equals to I0 e minus kcx. This is the Beer law. After include of both laws, we can say that Lambert Beer law, that is Ia is equals to I0 minus I. I0 minus I is equals to Beer Lambert law. I0 intensity of absorbed light and I0 intensity of incident light. And I is equals to transmitted light. It is worth note that by the intensity of light we mean energy falling on unit area perpendicular to the beam per unit time. Intensity is proportional to number of photons falling on the unit area in unit time. As already we discussed, minus di upon I is equals to k dash c dx from Beer law, and upon integrating after that log I upon I0 2.303 log 1 upon I upon I0 is equals to minus k dash bc. This is the equation number 5. In this equation, Beer-Lambert law that states that intensity of monochromatic radiation decrease exponential with decrease in thickness x and concentration c. This is the important paragraph. Here is k dash upon 2.303 is equals to epsilon I upon I0, that is the log I upon I0 is equal to absorption A, and I is equal to log I0 upon I. Epsilon BC is epsilon absorption coefficient. Here is the graph calculated between absorption and C. See here the slope epsilon B. So A is equal to epsilon BC. Transmittance, we can say that absorbance and transmittance are inversely proportional. 100% transmittance, then absorbance is 0, and absorbance 100% transmittance is 0. So transmittance is T is equals to I upon I0. Then relative of absorbance by the equation A is equals to minus log T. T is equals to 10 minus A, that is 10 minus epsilon BC. Here is in the figure, one is transmittance in percentage and the concentration. Concentration increase, then transmittance also. This is the graph between C and T. As A versus C is a straight line passing through the origin, it is easy to interpret it compared to the percentage T. Hence, modern sophisticated spectrophotometers are generally calibrated to read absorbance, although they directly read transmittance. Limitation of the Beer-Lambert law. This is the important, because in this examinations, some examinations ask some types of question. What is the limitations of the Beer-Lambert law? The first limitations is the Lambert-Beer law is followed only if monochromatic beam of light is used. First conditions, light is always monochromatic light. Second is, this law is applicable to dilute solution. Beer-Lambert laws are used in only dilute solution. Only particularly in case electrolytes where interoionic interaction disturb the ability of the solute to disturb light. Hence, A versus C is non-linear. Temperature should vary appreciably as with increase in temperature there is bathochromic shift, that is the absorption shift towards longer wavelength. Bathochromic shift known as the red shift. shifting on red area. Grothus-Draper laws. Next, laws of photochemical laws known as Grothus-Draper's laws. This laws was given by Grothus and Draper. So we can say this laws known the name of the discover Grothus and Draper. Grothus, Draper and Grothus and Drapers are advocates that all the light that was incident upon a sample is not effective is bringing about a chemical change. Only that light which is absorbed by a system brings about photochemical changes. This law is also known as principle of photochemical activation. Next law is the Stark-Einstein law, photochemical equivalence. This law is also known as the principle of the quantum activation was given by the Stark and Einstein in 1903 to 1912 respectively. According to this law, one quantum of radiation activates a single molecule in primary step of the reaction. This law does not mean that one molecule must react for the absorption per quantum of the light. If radiation of frequency nu is absorbed by a substance, then energy of quantum of light will be h nu. Therefore, energy absorbed per mole of substance will be is equals to nh nu is equals to nhc upon lambda, because we know that lambda nu is equals to c upon lambda, that is E is equals to nhc upon lambda. The energy absorbed per mole of the reacting substance is known as Einstein numerical value of which inversely proportional to the wavelength of absorbed light. This is the law of photochemical law. Now we discuss on quantum yield. This is also one number questions according to university exam. The law of photochemical equivalence is restricted to the primary photochemical process only, that is, each reacting species excited by the absorption of one radiation undergoes chemical transformation and product obtained does not undergo further reaction is not applicable to secondary process. For reaction where there is the 1:1 ratio of the number of quanta absorbed and number of reacting molecules, quantum of yield phi is one which is the expressed in phi is equals to, here phi is the quantum yield. Quantum yield phi is equals to number of molecule reacting in given time upon number of quanta absorbed in same time, or phi is equals to number of moles reacting in given time upon number of Einstein absorbs in the same time, or rate of chemical reaction upon number of Einstein absorbed. It is worth nothing that 1 Einstein is equals to 1 mole of quanta of radiation. As primary process, activation of molecule is followed by secondary process in which chain reaction may set up like as chlorination and methane, and in some cases deactivation occurs. Hence, quantum yield of a reaction may be greater than or less than 1. That is, the phi is greater than 1 or phi is the less than and equal to 1. Quantum yield may be as high as the 10 to the power 6 or low as the 10 to the power minus 2. A contradiction of law of the photochemical equivalence. So today we discuss on some topics like as photochemical laws, and second is the quantum yield Photochemical laws are three types we discussed: Lambert, Beer, Grothus Draper, and Stark Einstein, and quantum yield. You prepare your notes with the help of PDF and complete your assignment, and like and subscribe my YouTube channel R Chemistry Class. Okay, thank you so much.